would just like to ask her to come up. Thank you.
Hi everybody, I'm Mary Bourke. I'm from the Department of Geography in Trinity College Dublin, and I'm going to speak to you today about a new initiative that we're beginning in Trinity to deal with the issue of floods in Ireland, and it's called Natural Water Retention Measures. So if I could have my slides, or are they? Great. So what is natural water retention measures? What are they? Well, they're green infrastructure, and they have multi-functional aspects to them, and they can help us in trying to alleviate some of the catchment scale flood risks that we experience here in Ireland. And what I want to focus in today is on multifunctional. I'm speaking to an audience that's interested in biodiversity, not an audience that's primarily interested in floods. So we'll talk about these multifunctional aspects. In essence, what we're trying to do is keep the water in the landscape for longer. We are not flooding farmers' lands, farmers' livelihoods. We're talking about retaining the water, slowing the flow for between 12 and 24 hours, just keeping it where it is, just for a little bit longer. I lived in Australia for quite a while, and they had this great phrase of do what you can where you are with what you've got. And that is underpinning this approach to nature-based solutions in water management. We have a landscape that has a natural topography, and it's about looking at that topography and seeing opportunities where we can delay the connectivity of floodwaters in that landscape naturally, sustainably and naturally. So here's one of the examples. If you look on the left here, we're looking at, on your left, we're looking at leaky dams. Now, leaky dams are dams that are designed to leak, highly counterintuitive. They're using natural materials such as these native species that have been locally cut down. During a flood event or a flow event, these dams will basically have water standing behind them for longer periods of time. So we're looking at perhaps a damming of the water here that might be in the order of 20 seconds, just slowing it a little bit. And the idea is that you have a large number of these small interventions dispersed around the catchment. They are low risk and they are low cost, and they are effective. In looking at peatlands, and again, this idea of working with nature, working with what you've got, we know that particularly in Scotland, in terms of trying to restore and rehabilitate peatlands, they have combined this approach with dealing with flood problems. And they've put in these natural turf dams, so bits of peat across, at frequent intervals that store the water and then allow the water to infiltrate into the peat itself, but also slowing that and lowering that flood peak. And I'm delighted to say that at Trinity, the Provost Prize, and along with our partners at National Parks and Wildlife, we're beginning a project this year to look at the potential of Irish peatlands for this particular approach in slowing down the flow. One of the things that we tried to do, and that was peatlands, we're looking at reconnecting rivers with their own floodplains. The floodplains belong to the rivers. The floodplains were built by the rivers. And through a series of arterial drainage network schemes, we have cut off that connectivity between the river and its own floodplain. Ireland is a system, a geomorphic system, a terrain system, where we actually have a lot of low gradient river systems. And naturally in those systems are these broad floodplains that have all of these paleo channels, former pathways of the river itself that are these natural lower topographies in the floodplains. And what we would aim to do was reconnect the river with its own former pathways so that when it floods, it basically can put that extra floodwater in its own paleo channel, and it's going the long way around and come back into the river, slowing the flow. Forests are another area that we're tackling in terms of looking at the potential of forested lands for natural water retention measures. Now, of course, there's loads of different types of forests. You can have whole catchment styles, you can have smaller belts, you can have floodplains and riparian woodlands. What's interesting, I suppose, to this audience is that not only do they provide ecosystem benefits in terms of floods. But there's all of these other benefits in terms of habitats, climate regulation, low flows, aesthetic quality, etc. So working hand in hand with these natural water retention measures, we're providing a space for other additional ecosystem services to thrive. So we have co-benefits from biodiversity down to reduced soil erosion. And again, I'm delighted to announce that this year we've just received an IORC PhD scholarship in partnership with the OPW, that agency, that government agency that's been given the role of helping us with our flood problem. And so we're going to look at forested areas in particular with the OPW to look at how we can integrate natural water retention measures in forested areas. And then we come to agricultural land. Agriculture has featured very heavily in this conference. And talking about how we can work with farmers and with communities to increase our biodiversity benefits. Now, I think many of us in this room will have seen this. Will have seen dirty water on our farming, our rural roads. And what this is showing you is that the soil, the water, the nutrients, the hidden world of microbial systems is all being washed off the land out onto the road and down into the river systems. And this is a negative outcome in terms of rainfall on agricultural land that's been freshly ploughed. An example of where natural water retention would come in and help this would be the construction of this earthen bund in the corner of a ploughed field that would retain the water to a certain point, and then it has an outflow pipe where the excess water would then be draining off out of this soft engineered earthen dam. And so you're retaining the soil and you're retaining the nutrients, and so it's having an impact not only on floodwaters but also on water quality. So the essence is to reduce and enhance catchment processes, the ones that have been affected by human intervention, with the ideal to reduce flood hazard, either by planting trees, by using floodplains that exist and just storing the water there for a little bit longer, or producing these leaky dams from natural materials, sustainable approaches to managing the floods. Does it work? Yes, it does. So here's some data from the UK. This is a catchment, the Stroud catchment, and the green graph here is the flood hydrograph. So this is the amount of water on your right-hand side there, on the bottom is time. So quite a flashy kind of flood in 2012. And after that flood in 2012, they decided to adopt natural water retention measures approach, and they installed 280 interventions in their catchment. And this is the resultant flood peak in 2016, with very similar initial conditions in terms of the rainfall input. Now, this is a small catchment, and so it has been demonstrated quite strongly that this approach works for small catchments, but does it work for large catchments, and does it work for big floods? Well, simply you'll hear that it doesn't, but that we don't know. The data has not been collected. It's been modelled and suggested that it doesn't work, but it's not been proven. We need data on the larger catchments and the bigger floods. And Ireland is heading for a bit of a troubling time in terms of our climate change. We have here analysis of rainfall records that's showing that basically the areas in blue and brown represent areas where the soil will reach saturation point both earlier and later in our season. Therefore, we're going to have a longer flooding season in Ireland as a result. Now, what does that mean? Well, we can look at an area in Donegal, the Inishowen Peninsula, that in the month of August, you can see here the blue on this graph is this cumulative rainfall. Basically, the amount of rain that fell in that month of August exceeded the mean quite dramatically. So that means that all of the land was saturated, the soil was saturated, so its capacity to absorb water was reduced. So you had areas of standing water in fields like this. Then we had an offshoot depression from a hurricane cross the Inishowen Peninsula, Hurricane Gertrude, and it brought the highest daily rainfall, 77 millimetres, fell on that day. And so we had a condition where not only was the water saturated, but even if it had been a drought-like year like we've had in the last year, it fell so intensely that basically that's my own timer, that it fell so intensely that the water wouldn't have had time to penetrate and get into it. And so as a result, Carndonagh and other areas in the Inishowen Peninsula were absolutely devastated by this event. We had extensive inundation of agricultural land, we had landslides into people's homes and on farmlands, and we had damage to infrastructure. Now, will it work? Will natural water retention measures work for the big floods? Well, we don't know. But I would say that that's not actually where our energy should be diverted. We have floods of many different magnitudes in Ireland. We have small floods that occur frequently and large floods that occur less frequently. It's been shown now in a concept developed in the United States, this concept of nuisance floods. These are the ones that come up and flood your driveway or block a road and you can't get to work, or somehow inconvenience lots of economies. And if you have more of those floods happening that have a cost associated with them, they will sum total up to being a more expensive type of flood than the big one that happens in the so-called 1% flood or one in 100 years. So I would suggest that natural retention measures will benefit these kinds of floods, and in such would benefit bigger floods just by the natural presence on the land. So this is the beginning of a project. We have funding from the EPA, thankfully, and we have lots of agencies combining with us to help us move on this. So thank you very much for your attention.
Thank you very much, Mary.